Sequences and series unit, and we're talking about infinite geometric series. This is part 2. We have the generation of a series given by the terms 5 plus 4 plus 16 over 5. And I'm going to try to generate right now what I believe the next term of the sequence is. Something that I notice with these types of problems is like 5 probably has some sort of like n next to it or n factor of it. And then the next term up being a 4, somehow that 5 went away. Then we continue on with 16 over 5. I'm kind of wondering if, for example, the fact is that 4 is 4 to the first power, 4 squared. So maybe there is a 4 in the first term. It's just 4 to the 0. And then the fact that there's a 5 and then the 5 goes away maybe tells me that I have 5 in the denominator, but it's 5 to the 0 power, so that over here I have 5 to the first power. And you know what? If I carry these elements of the exponents back, this is probably 5 to the negative 1. You know, a negative exponent would flip it. So I'm looking at a 4 over 5, 4 over 5, 4 over 5 consistently, and I can probably project that the next number is going to be 4 to the third power over 5 squared, or 64 over 25. 4 to the fourth over 5 to the third. Gosh, can I do that one? I think it's 256 over 125. And so we're able to continue generating new terms of the sequence. I therefore think that this sequence is generated by the sum from, let's do n equals 0 to infinity of 4 to the n over 5 to the n minus 1. You know, if I break up that n minus 1 like this, I can break this up to look like from n equals 0 to infinity of 5 times 4 to the n over 5 to the n. Now, I did that because I'm just breaking apart the exponent n minus 1 into n minus 1. And then the fact that there's a 5, kind of like I used the explanation of logic right in this step over here with the 5 to the negative 1, that's actually, you know, on the top of the fraction. I'm just going to put that back up there. Yeah, okay. So then 5 is going to be our initial number, if we're going to be using the geometric series way of calculating what the series summation is. And then 4 over 5 is our R value. You know, we can separate the n, that is the power of both of them, to just say this is 4 over 5 quantity raised to the n power. So R is 4 over 5. Therefore, S, the summation of the series, will be the initial term, a sub 1, over 1 minus that common ratio, 1 minus 4/5. And substitution lets us know that's 5 over 1 minus 4/5. 1 minus 4/5 is 2/5, so we have 5 over 2/5. Fraction on top of a fraction, we can reduce by flip and multiply. That's reciprocals, and that means the 2's and 5's will cancel. 25 over 2. I don't see 25 over 2 as an answer. So let me just check and see, and I guess this is where I'm going to say maybe I'm wrong, but I want to figure out, you know, what I need to see why that works. Show a step-by-step solution. I did that part. How is my math? Oh my word, you probably were screaming at me the whole time. Where's the 2 coming from? Where's the 2 coming from? Where's the 2 coming from? I don't know. I thought 1 minus 4/5 is 2/5. It's 1/5. 5 over 1/5. All right, thank you for watching this video. Thanks for letting me troubleshoot why I got the answer right and wrong at the same time. That's like Schrodinger's cat. Appreciate it. Watch some other videos. See if these are going to help you out. Appreciate it. Bye.